As the world moves towards a lower carbon economy, then we will see electrification in many areas. Electric vehicles are one, but the battery technology at the moment doesn't fully meet the customer's requirements. The Faraday Institution exists to fund research in electrochemical energy storage, at the moment in particular into batteries and more specifically batteries for electric vehicles. Our philosophy really is take a big challenging problem, get some very smart academics at some very good universities working collaboratively together to tackle those problems. The work here at Birmingham is really focused on the recycling project, but all of our projects involve a consortium of universities.
The ReLiB project is designed to tackle all the legal, regulatory and technical problems in order to create a recycling industry for lithium-ion batteries in the UK.
So the overall goal is to recycle at least 95% of the materials in the battery, which is extremely challenging.
There are three main hazards associated with end-of-life lithium-ion batteries. There's a high voltage hazard, there's a fire hazard, and there's also a toxicity hazard. In order to try and reduce these hazards, and also to recycle the batteries more economically, we're very keen to automate as much of these processes as possible.
I've previously worked on projects where we've looked at robotics segregation of motors from electronic waste in the automotive sector. And in this project we wanted to implement similar technologies but into the battery space.
So long term we obviously want to tackle all of these technical challenges with electric vehicles and battery technology. But the Faraday Institution's remit is much broader than that. So we can look at other electrochemical energy storage technologies and we can look at other industries. For example, there's an appetite to look at grid storage, batteries for aero, maybe rail, heavy-duty vehicles. So we will see where the most interesting challenges are as we expand our remit going forward.